Yes, the next slide, please. Yes, to introduce myself, I'm Pete Thomas from the Transport Safety Research Centre at Loughborough University, and I'm the coordinator of the Levitate project. And in this section of today's webinar, first of all, I'd like to just say something very briefly about the project and what we're aiming to achieve, and then hand over to my colleague, Bin Hu, at the Osborne Institute of Technology to talk about a specific area of freight transport where we've been looking much more closely. Next slide, please, Bin. First of all, to very briefly say that that Levitate, which stands amazingly for the societal level impact of connected and automated vehicles. It's a project that's funded by the European Commission and which started in December 2018 and continues through to the end of November last year. And we have a partnership that involves 12 separate institutions or companies, and I'm very pleased to say that we have a membership including partners representing cities and cities themselves, but also partners from around the world. So we're able to tap into global expertise, and also we hope to have a global impact with this project. Next slide, please. So why do we have this project? What's it about? Well, the project started from the perception that there are very high levels of interest, public interest, in the new introduction, the rapid introduction of both connected services and automation. And this is something that's really caught the public's imagination. There are very high expectations of them, and particularly in the area of safety, but also in terms of the impacts on mobility, environment, and the economy. But nevertheless, many of these expectations may or may not be embedded with quantitative evaluations. And also many of the expectations are based on some sort of understanding, a very loose understanding of the technologies involved, and not necessarily about the potential for societal level impact. And so this is what the Levitate project is about. We're taking the introduction of the technologies as something that will happen, but we're asking the questions about how can we start to forecast the impacts that these will have at societal level. And when we're looking at this, we realize that there are a very wide range of impact types. Safety, mobility, and the environment are some of those, but these extend much more broadly and potentially including things like land use, public health, local economies, many other dimensions. Next slide, please, Min. So the purpose of Levitate is to start to build tools really to help cities, the regions, national governments as well, to prepare their own forecast, to get a common understanding that's embedded with a much better quantitative evaluation, to prepare for the introduction of connected and automated mobility services. So our aim is to develop an impact assessment framework, really to help policymakers manage this whole introduction and their responses to these new technologies. Next slide, please. So we're dealing very specifically with a small number of challenges. First of all, much of what we're hoping to do is based on vehicles or connected services that do not yet exist. So we are looking at forecasting methods to help cities understand this, either in specific applications, as you'll hear today from Bin, but also in terms of developing methodologies that can be applied much more broadly. And so we're dealing with two main questions that cities in particular have, and the cities are essentially our target audience. And these two questions are, first of all, what should cities, urban authorities be doing in order to respond to the introduction of connected and automated vehicles? And secondly, how can they use these technical capabilities to help them reach their key policy requirements, which may be in any of the city policy dimensions that they may have. So our challenges are to prepare a framework in which we can forecast the impacts, both in the short term, the medium term, and the long term, using quite a wide range of forecasting methods, and to do our best to ensure that the results are as applicable to a wide range of types of city as possible. So next slide, Bin. I'd like to hand over now to Bin Hu, who will describe some of the work that we've been doing generally in the freight use case within the project, and also to deal with some specific forecasting that he's already started working on. So Bin, over to yourself, please.
Okay, thank you, Pete. So I will continue with the freight use case. Generally, in Levitate project, we have 3 use cases, namely passenger cars or private cars, where the focus is more or less on the regulation options from on the city level to handle these AVs. Then we have urban transport, where the focus is on automated shuttles in many variations to support the public transport system. And our focus today is on the freight transport, where we will look into some applications, and one application specifically, namely the automated urban freight delivery. Talking about the freight use case in connection with automated vehicles, we can think about lots of technologies. For example, driverless cars for the container transport, automated vans with robots for delivery. Then we have all kinds of automated pilots for the highway. We can use control centers to control trucks in case of emergency. If there is no emergency, then the truck could drive on the highway. All these technologies are not so much the focus of this project, but we are thinking about how can those AV technologies bring into conceptual changes. So the real question is, will the freight transport system change with the introduction of these new technologies? And less about what kind of new technologies will arise, and we will also not develop any hardware technologies in this project. And what are the impacts when we change the transport system we know today? And our assessment methods for these impacts are mainly coming from 2 directions. On the one hand, we have operations research, which involves optimization methodologies for, let's say, macro level planning from the viewpoint of freight operators. Because freight transport is plannable, therefore those freight operators will mainly have their focus on the economic gains, and the concepts should be economically viable. And then we have micro simulations to assess the traffic impacts. The first application we looked into in this freight work package was the automated urban parcel delivery. And we compared between several possibilities. The first one we are taking just for reference is the manual delivery, where we have a personnel, a driver, and this driver usually also brings the parcels to the users. And then we have the semi-automation as a possible scenario, namely where we have the delivery van as a connected automated vehicle, but still we have some personnel who does the delivery task. The reason is some obstacle for automated delivery is the infrastructure, namely where to place the parcels or how to hand over the parcels to the people. I mean, as we are seeing today in the coronavirus, the system kind of works where we don't have a direct communication between the users and the delivery personnel, but in the long term, we still need some solution. For example, boxes where to store those parcels. So in between, we might have a scenario of semi-automated delivery. And then we have as the third or final scenario would be full automation, where we envision a van, which is an AV, and this van carries the parcels and some robots, and the robots will do the last section of the delivery. Comparing the assumptions of these three scenarios, we can say that the manual delivery currently involves shifts of 8 hours, roughly 8 hours, and the capacity limit is around 230 parcels, at least in Germany and in Austria. And in average, we can deliver 3 parcels per stop and 5 minutes per stop. In the semi-automation scenario, the main improvement is that the driver doesn't have to drive anymore, or the personnel doesn't have to drive anymore, and we gain some minutes because he doesn't have to shift between driving task and delivery task. So therefore, we cut the required time for each stop to 4 minutes. In the third scenario, the full automation, we can have 3 delivery shifts because we can also do night deliveries where the traffic is actually lowest. But here the capacity of the vehicle, we assume it to be like 100 parcels because we cannot just stuff the van full of parcels. Otherwise, the robots will have some problems picking the parcels. And these are assumed to be the limiting factors for the manual delivery and the semi-automation. This is the shift length, and for the full automation, this is the parcel per tour. And talking about the assessment methods, as described earlier, we have the micro simulation for traffic indicators on a small area, and then the results will be scaled up by operations research, which is a macro level method, where we assess the other indicators and upscale the micro simulation results. The micro simulation, we are working with the Aimsum Next tool, which is a traffic micro simulation where we model the vehicles and the streets and also the background traffic. For Vienna, we took some examples of areas. Here we see an example of rural area where we have a delivery route of 3 kilometers. And then we have a repeated parking and driving model for the delivery task, where we say that the delivery van is halting every some 100 meters. And then we measure the congestion or delay caused to the background traffic and also measure the number of conflicts. The results of the micro simulation, to sum up, was that for the congestion, the difference between the manual van and the automated van is not so great on the background traffic because there is only one vehicle involved, and in the background traffic we have many other vehicles. And the full automated delivery during night causes nearly no delays because there are no other cars or very few cars otherwise on the streets. And for the safety, we also have no significant difference between the manual van and the automated van. This is also only with respect to the background traffic. Of course, there are some minor differences if the vehicle has to park into some parking lot and exits the parking lot, but the overall picture on the background traffic is quite minimal when it comes to the impact. Then talking about operations research, we are basically using VRPs, or vehicle routing problem. We took the map of Vienna and some data we got from the freight operators. We have two distribution centers, one in the northeast and one in the south, and they service different districts. And as an example, for the 6th district, which is quite urban, we just model the tours required from the distribution center towards the area of delivery, and then the delivery route consists of 8 tours or 8 vehicles, and we can obtain the average length, which is 35 kilometers. We can obtain the driving time and also the parcels delivered to this area. And with this methodology, we can see a full picture of Vienna, where we do an individual planning for each of the districts and then sum up all the results. For the fleet size, we see that the manual delivery, or the status quo, requires some 470 vehicles and staff personnel, of course. And by applying semi-automated delivery, we can reduce the number of vehicles due to the capacity increase, because we can do more deliveries in the same shift of 8 hours. And for the full automated delivery, we also require a very similar number of vehicles. On the one hand, we can do 3 shifts per day because we can operate during night. But on the other hand, we assume that the capacity of the parcels will decrease for each vehicle. And then for the total kilometers driven, we can see that actually for the fully automated delivery scenario, we are increasing the mileage because we do 3 shifts, and therefore we are increasing the kilometer driven by 242%. For fleet operation costs, which is quite relevant for the fleet operators, we use some assumptions. Namely, we have costs for the conventional delivery van, which is assumed to be 14,000 euros per year. Then we assume some costs for the AV van. We don't know for sure, but in this scenario, we envision that this is in the far future, or after 10 or 15 years, and then the AV technology will be not so expensive anymore as they are today, and it will cost 17,000 euros per year. And then the delivery personnel is the main chunk of the costs. We took the costs from Austria as comparison, where we have 1 driver or delivery personnel per van. And then a big question mark are the delivery robots. Here we envisioned a variant, or we took our assumption from the Starship robots, which has some costs around 6,000 euros, where we assume that they have a lifespan of 3 years. Then it comes down to 2,000 euros per year, approximately. And we have 6 robots per van. And also in the fully automated delivery scenario, we require some monitoring personnel. We assume 1 is enough for 5 vans with some costs of 60,000 euros per year. And adding everything together, we have a picture like this, where we have a required fleet size, as in the previous slides. Then we have a cost per vehicle, and then we have a total cost. And here we can see that roughly the cost can be reduced to 56% if we replace all the delivery system by full automated delivery, which operates in 3 shifts per day. So 1 day shift and 2 night shifts. And for the other traffic indicators, the delay induced into the traffic, here we can see that going from manual delivery to semi-automated delivery, we can reduce the delay by 25%. And then for the full automated scenario, it is around the same as semi-automation, because we do induce some minor delays during night, and in overall we do have a increased number of kilometers for all the vehicles together. And the same picture applies to the number of conflicts. So the conflicts, it's not directly translatable to accidents. These are just conflicts, and depending on the model we are using, it is also dependent on the region and on the streets. There are some works necessary to translate them into number of accidents. To conclude, under our assumptions, where we took them from available data and some others from just reasonable thinking, we can say that automation in freight delivery can decrease the operation cost significantly, because the most expensive part is still delivery personnel or the drivers. And then, of course, the major change comes with delivery towards night shifts, because during the night, people don't want to work in the current system. But if we are applying automated delivery, then there is no argument against using the delivery during night, where the traffic load is actually lowest. And then some future use cases in freight we are addressing is, for example, automated delivery via white label city hubs. I think this is very relevant for the cities. They want to consolidate the freight transport or the parcel delivery, and how can automation help with this respect? And also the highway platooning is a very mature application already. But for example, what will it change when we are thinking about the bridge infrastructure? For example, on urban highways, we have many bridges, but highway platooning means that we have more vehicles per kilometer, and this will cause more weight on the bridges. So do we have to react to this, for example? So these are just two examples how we will proceed within the Levitate project in the freight work package. So that's it from our side, and we thank for your attention. And I think there will be a Q&A section at the end of the webinar. Is this correct?
Yes, it's correct. So I also would like to highlight that after the 3 presentations, we are going to have a questions and answer session. So please feel free to ask your questions in the chat panel. There are already some questions arrived to Bin, but I'm only going to read them after the 3 presentations. I would like to invite the next presenter, who is Fernando Lieza. I'm going to give you the right to be a presenter, Fernando. And here you go. You are muted, I think.
Sorry. Thank you, Bala, for the introduction, and also Bin for the very nice presentation. Let me introduce myself. I'm Fernando Lieza. I'm the Secretary General of ALICE, the Alliance for Logistics Innovation through Collaboration in Europe. And today I'm going to explain a bit what's our vision on the future impacts of automation in freight transport, and what we are doing, and how we envision this could help us in reaching our goals. So first of all,
we cannot hear you anymore.
I was mute, I don't know. The European Technology Platform for Logistics, ALICE, was recognized by European Commission as the technology platform. This means that we provide recommendations for research and innovation programs, and in this case, the Horizon 2020, and we are also quite active in providing recommendations for the next Horizon Europe program. To do that, what we do is to look into the potential futures ambitions for freight transport and logistics, and try to identify which are the challenges to reach those visions, and then define research and innovation gaps, build consensus, and share and try to get them into the work programs, for example, the ones that Levitate were funded out. Then the second thing we do is that we also liaise with the projects that are relevant for the implementation of our roadmaps and features, like Levitate. Levitate is an ALICE project, and in this context is in which in the context we are participating in this webinar. And thank you, Balazs, for the organization. And then the third one is that looking into our membership, we are now 140 members representing different type of stakeholders interested in freight transport and logistics: shippers, retail, manufacturers, logistics service providers, postal operators, parcel operators, freight forwarders, also hubs, infrastructure managers, vehicles manufacturers, also companies dealing with modular loading units, handling units for freight transport and logistics. Of course, a number of ICT and consultancy. We also gather regional clusters and research centers, and we collaborate with many European technology platforms, and we also have a link with the member states through our mirror group. As I said, we are 140 members, and we have very different perspectives, and with these perspectives we try to raise consensus from an holistic point of view to the futures of freight transport and logistics. But we also, of course, we have a very nice ecosystem in which the members can really collaborate with other members, so fulfilling our mission of collaboration innovation in Europe in logistics. So here it's a representation of how we envision the future. What we see is that currently transport modes operate in a very isolated way, and they are not fully utilized. There are many walls in between them, not only physical but also digital information, and this is preventing full utilization of the transport system. And this is the challenge, and what we would like to envision is our dream where there is no wall between the transport modes. It's more connected and better utilized, and here you can see a lot of role for the connective and automated vehicles. But it's not only about transport, it's also how the users of the transport are using it. So then the supply chains are more open, and the resources are shared, so then flows can be combined in a better way, so then we can pull flows and get them transported in a much efficient way. Then all this is because we endorse the vision of zero emission logistics for 2050 and the zero emission city logistics in 2030, and we created a roadmap on the different interventions and the different opportunities we have in the short term to reach to the goal, and in particular to meet COP21 objectives. In the area of cities in particular, we are strongly collaborating with Polis and establish a strategic dialogue. And what we are doing in this dialogue is to identify how industry can help cities in achieving this zero emission city logistics by 2030, but also the contrary, how cities can help the industry in moving towards this vision. So going into the webinar, so then how can automation help us to achieve our goals? So then for us, automation is not a technology, it's a tool to help us reaching our goals. And I'm going to share some of the potential ways this could happen, and some of them have been already mentioned, so then I will not explain them lengthily. The first thing is that, and also extending what Mr. Bean was saying, is that how our infrastructure is used. While we see during day infrastructure in many places is congested, very congested, we see that at night infrastructure is not used. Of course, at night, traveling at night for people is normally not a good idea, at least for the moment. When the automation is coming, maybe it's easier. But then for freight transport, we think it could be a way to shift some of the demand for the infrastructure during day to night. And this is it's of course complex, because there are more barriers for doing this at night. But on the other hand, once you think on automated vehicles, maybe the speed they need to travel could be less than the speed they need to travel now. The second case is how automation can help intermodality. Here we see, and it was in one of the pictures before, this project, it's Volvo and Anvera. And here the good thing, or the interesting thing, is that one of the problems that is preventing intermodality is the high cost of the last mile between the terminals and the warehouses and the customers. So then, and in particular, this could happen in big logistics hubs where there are terminals, could be ports, could be internal terminals. So then the different containers could be transported in an automated way to the final destination in the warehouses. Normally, in many places, these are semi-confined areas. So then there are larger logistics platforms, like, for example, in Zaragoza, where I live, where many companies have their warehouses. So then this could be a potential vision or future, that there are these fleets of automated vehicles that could automatically drive the containers from the terminals to the warehouses. Then a future, and this was already mentioned, but here what I want to say is that this is not that far away. Already Valeo delivered and unveiled a fleet of electric automated vehicles to deliver e-commerce in China. And this year it's very interesting, because it's not only automated, but it's electric. And this combination is making them a good combination for us to reach our target of going zero emissions. And in particular, this, as been said before, these systems are for the moment more expensive, but on the other way, if we think on different ways of operating them, we can also save some money, as the need for people, it's not in the whole process, but only part of the process. It's also important that how automation can act or help on energy consumption. So then now we have that in long haul, the freight transport speed is really defined because of the truck driver resting hours. So then this means that most of the times trucks need to go to the full speed. So then they minimize the time in transport. But when this limitation does not is not anymore in place, then we could even envision other scenarios in which the trucks goes at a lower speed. And for example, if this is combined with a transport at night, then could be a reduced speed. And then the important thing is that the trucks arrive to the final destination on time for the handling of the goods at the destination. Of course, this is also creating some additional constraints and limitations how to manage these different speeds in infrastructure, but it's a potential future. And also how this could impact the total cost of ownership, because at the end, if you go at a reduced speed, this means that you are delivering less value per minute, I would say. Then one important thing is that currently in many countries, in particular in Germany, but in UK, in others, there is a lot of concern because of the drivers shortage, and most of the drivers in our European countries have more than 50 years, and this makes that in 10-15 years we are going to have a bigger shortage. It's also important to say here that it's now very difficult to convince young people to be a long-haul truck driver, because at the end, if we are talking about automation, we are asking them to start a career in an area that may not stay here for their full career. So this is also an interesting problem to tackle. And just to finish is also how automation can help us in this kind of conditions. So for example, now we have a lot of problems on truck drivers at the start of the crisis, not willing to enter Italy, for example, or now Spain because of the situation with the coronavirus. And then even those in entering the country were afraid that they could not come back. So then this is a potential case. Now another case is that it's how now riders for last mile delivery, they are quite a lot exposed to the virus. So then these combined systems of autonomous and human deliveries could help a lot. So then all these cases we are putting them as part of the scope of the next partnership within Horizon Europe that has been proposed very recently on connective, cooperative, and autonomous mobility, CCAM. So here we are partnering with other stakeholders like AirTrack or UCAR and police as well, and many others, to frame a proposal for a partnership for the next Horizon Europe program. And I'm not going to explain it in detail. If you want to know more about it, you can ask me, or you can also ask AirTrack, and I will be happy to provide you with more information. Here, the message is that we are quite interested and really amazed of the opportunity to collaborate with the whole sector, trying to deliver value for the society. So we expect to get some answers to the questions you all have about the cases, but also to gather new ideas and think out of the box how we could better use these systems in the future. So here it's my question for you. So what's your idea? How you think automated vehicles and autonomous mobility could really impact freight transport and logistics? So then we can get them into our discussions in ALICE, so we frame good research questions for the future programs. And that's all on my side. And thank you for your attention, and happy to get your questions afterwards.
Thank you so much, Fernando, for the interesting presentation. Indeed, we are still welcoming the questions to direct it to Fernando as well in the chat. And I would like to invite our third presenter, who is Chris Nyens from the Flanders Innovation Cluster for Logistics. I'm going to give you the floor, Chris. I made you the presenter.
Okay, I hope everybody can hear me, and
Yes.
I'm going to share my screen. Let me see how this works, whether I can get on the, let me see, I want to go on, so I'm just trying to make some room here so I can get into the presentation. Here we are. So normally, I hope you guys
Yes.
get a full screen now? Okay.
Exactly.
Okay, perfect. Welcome everybody. Well, not welcome. I dropped in a little bit late. Fernando already mentioned the COVID-19 crisis. We're also very much involved in that. So, but I could pick up a few of the last slides of Fernando, and there have been many interesting references. I have about 15 minutes. I will try to be as concise as possible. This presentation is about the ALES demonstrator. ALES stands for Autonomous Logistics Electric Entities for City Distribution. And it is a project we have executed about 2 years ago. Who is VIL? VIL is Flanders Spearhead Cluster for Logistics. We are active in 4 domains: digital transformation, green supply chains, last mile hinterland connectivity. And it's not a coincidence that there is a lot of overlap with the working groups or the roadmaps of ETP ALES. We do 5 things. We are active in projects and valorization. We're a network organization with about 600 members. We are internationally active. We provide some policy advice and some training and education, but the focus is really on projects and valorization. And one of these projects is the ALES project, or was the ALES project. It was a regionally funded collective research and development project run by us. In the background, you can see the participants, ACP, Belgian Post, Bring Me of the Lockers, the City of Mechelen, Port of Antwerp, Trimble, Rhenus Logistics, but also the DHL that you will see in the background. And it's interesting that Fernando actually mentioned one of the drivers for one of the participants is effectively the lack of drivers and the fact that they're constantly struggling with that. So that's not only for the participant DHL, but also for other parties. So an interesting cross-reference there. What you see is that the objective of the project was initially to have the logistics sector, together with cities, jointly determine the prerequisites for deployment of autonomous vehicles for logistics operations in cities, more specifically concerning parcel delivery. And the final objective was effectively to have such autonomous vehicles be part of a later effective implementation of the vision in which physical goods are delivered, stored, and used in the most efficient and sustainable way. And that is, of course, the physical internet vision. Important to note is that when we set out on the road in this project, we were not fully aware of the state of the art of the technology that was already available in the market. And that was mainly for passenger transport. But as you will see when we go into the technology, this is basically how LiDAR technology works on a vehicle. So it's heat mapping. We worked in our project with EasyMile, but it could just as easily have been Naviatech, who are basically the 2, I would say, leaders in Europe right now where it concerns autonomous passenger transport. And you have a view here on, I would say, the technology used. You have the localization using data fusion, where it uses lasers, where it uses cameras, where it uses GPS, where it uses odometry, and where it uses the IMU is basically mobility unit or sensor technology on where it is, how it moves towards or in comparison to its environment. And then you have the decision-making safety chain. This split up of technology will later come back in how we got this approved for demonstration. And the decision-making safety chain mainly focuses on possible emergency stop, detection of obstacles, braking systems, etc. So really safety. If we continue, you see that why did we go to such a vehicle if you are looking for parcel delivery? Basically because it's a driving cube. So you see on the top left-hand side, you see an inside shot of such an EasyMile vehicle. So it's basically just some fiberglass and some chairs, but you see that there's a lot of space available. You have a few other examples of similar projects. On the top right, you see Renault concept. On the bottom right, you see Nuro is also a famous concept on food or parcel delivery on smaller parcels. And on the left bottom, you see one of our brain doodles where we just imagined how such a vehicle could look if you would combine passengers and parcels together, or it could look differently. But in any way, there's a lot possible just because of the fact that it is such an empty cube, basically. So if we go to the next slide, in the project, we also designed or we looked at approaches for an IT architecture, and that mainly clicks into how we have a vision on city distribution or city network logistics, which we will come back on later. But basically, you could have a direct connection between the players. You could have a neutral urban platform, or you could have an urban logistics data space. And why are we talking about this? Because if you would click an autonomous vehicle into city logistics network, the vehicle would have to be able to communicate, and the systems would be able to have to be able to communicate. And also, I would say the management systems of the local service providers should be able to click into that. So that was in collaboration with Fraunhofer. That is for sure well known to all of you. So you see, effectively, the neutral urban platform would be the best midterm service-oriented approach for stakeholders. But of course, on the long term, and also if we would move to a physical internet concept, then the best long term would be the open approach. But there, that's a new concept with limited references, so a lot of technology still needs to be developed. If we move to the demonstrator itself, what happened in the project is that we saw that the technology, state-of-the-art of the vehicles, of autonomous vehicles, was much further advanced than we anticipated. So the participants really pushed towards a demonstrator, and the city of Mechelen also was really supportive of that. And what was important, I would say, is that the legislative environment for the demonstrator was also constantly evolving. So there was already a little bit longer in place a regulatory framework by the Federal Department of Mobility and Transport in Belgium since 2016. And that was heavily based, I would say, on work that had been done in the UK and in the Netherlands. But it was, you have to imagine that such a framework is just basically a two-pager in which it says that you could do testing, but that you have to check with the federal government what you can do. So it's not much more than that. But more importantly, it was that during the project, it was clear that there was a royal decree in which we could, under which we could operate, and under which we could set up a demonstrator in a real-life environment. So, and this demonstrator was effectively the first in the public space in Belgium. And you see there's a split up between the federal responsibility and a regional responsibility. That's not just of the Constitution of Belgium, I would say, which is a bit specific, but you should really look at what it covers. And the Federal Department of Mobility mainly focused on the risk analysis, like how safe is this vehicle, what is the track record of this vehicle, and how has this been proven that the safety mechanisms work. So that is one. And then the other one is the Department for Mobility and Public Works, where the Agency for Road and Transport mainly focused on the suitability of the local infrastructure where we were going to perform the demonstrator. And that was really a very intensive exercise in checking how the local situation was and what the extra requirements were to make it happen. Yeah. What did we do? We had that autonomous vehicle running on the most busy shopping street of the city of Mechelen on a Friday afternoon, which in itself was not the most busy time, but still a very busy time. And here you can see what we did. We had the vehicle running amongst the public in that environment. And we had several stops, and we have a short video. Okay. Okay, so what, of course, this was just a demonstrator, nothing more than a demonstrator, and you saw that indeed the vehicle had not been adjusted. It was not built for parcels, but you could see that it was big enough already to have a roll cage, and you could actually work with different concepts. The cooling basically was just to demonstrate that passive cooling for city distribution was enough to cover 36 hours, so that should not be a problem. Now, mainly what I think is important is our vision on city logistics networks. And as already mentioned by Fernando earlier, I saw that indeed the use of night or slower times could be interesting. So our concept, basically our idea is that there would be an urban consolidation at the side of the city. And what you see here in Mechelen is that they have a very large part of restricted access or traffic-free zones. So you could have the delivery to a local microhub, for example, by an autonomous vehicle that is purposely built that brings volumes to the microhub, and then you could have a local distribution that either is done by an autonomous vehicle in combination with passenger transport or dedicated, but also very important, it could link into local last yard solutions, be it by Stint, Starship, crowd logistics, bike logistics, cargo bikes, whatever. So that's basically the idea, and then you would come back to the need for that high-level architecture. So I think it's time to discuss what is next. And perhaps some of you know that the OEMs, and that was also really interesting what I saw in Fernando's presentation, the reference or the cross-reference to Volvo for heavier duty transport. What is really, I think, interesting is that Volvo is probably the only OEM that currently has set up a service company to perform that service. And if you look at parcel delivery, we have two examples here. You have these OEMs, Renault with its EZ Pro, and especially Mercedes with its Urbanetic concept. And I would invite anyone that's interested to look up the Urbanetic concept on YouTube. There's many interesting videos. What you see is that the ideas and the concepts are there, but for instance, Mercedes is not pursuing right now this amazing concept because probably it just blocks their selling of vans. So it's still a long way to go. So that's why we believe at VIL that it's really important to continue experimenting, continue engaging in projects to really explore how these vehicles can be implemented. We are doing that in an Horizon 2020 project that will start later this year, where we'll really experiment how such a vehicle can click into other solutions. We see in the market, for instance, in Belgium under Labbox, that spin-offs of car importers are setting up services to develop such services. And it's also interesting to know that the city of Mechelen has really incorporated autonomous vehicles in its policy. So they are also looking into how these autonomous vehicles for passenger transport could also be a solution for parcel distribution. So that from my side is a short introduction to these projects. There you go. You can take the screen back if you want.
Thank you so much, Chris, for the presentation. And now we reach the end of the presentation. So now I open the session of questions and answers. As I see that the first questions are directed to Bin, I will send you an unmute request so you can. Yeah, you can talk.
Okay.
And the first
Can you hear me?
Yes.
Yeah.
The first question is from Himanshu Rai. In full automation, parcels will be reduced per vehicle to 100 compared to 290. How will it impact the savings per parcel?
So in our calculation, we see a decrease in cost, and this is mainly due to, on the one hand, we don't require personnel, which is the most expensive part in freight transport. And on the other hand, we see an increase in utilization, because for conventional van, we can only operate for like 8 hours, which is the personal working time. But AV van and robots, they can theoretically operate 24 hours. Of course, we have to take into account the maintenance time, restocking time, and we want to avoid the peak hours, but theoretically we can increase the utilization rate, and therefore we will achieve the cost savings. So this was the first question.
Yes. The second one is from Fernando. A very insightful presentation, in particular with a clear path on the combined deliveries futures, decoupling delivery and transportation, and maybe questioning full automation. Why did you focus your case on white label vans urban delivery?
Because we think that white label is the way in the future to operate, and particularly the cities, especially city of Vienna, they are having a strategy setting on white label deliveries, because all of us can observe, for example, in front of our house, we see in the morning a delivery by Austrian Post, and then 5 minutes later a van comes from DHL, at the same time one from DPD, serving the same streets. And if we can come up with white label solutions, then I think we can decrease the number of kilometers driven significantly. And also, this is the same case for the infrastructure, for the parcels. We do have some parcel systems for taking the parcels set up by Austrian Post, for example, but they only work with Austrian Post, not for DHL, not for DPD. If they want to set up some infrastructure, they will have to install such a box for apartments additionally, which doesn't really make sense. So we believe that white label solutions are the future, will be the future.
Okay, the next question is also directed to you from Claudia Andruetto. Very interesting presentation. Did you think of driving technologies, EVs, diesel, biofuels, and how this the increase in kilometer would affect sustainability?
So there was a discussion in the Levitate project. So to keep it simple, we assume that AVs will be emission-free, not restricting ourselves to electric vehicles, but emission-free, so either electric or hydrogen vehicles. For heavy freight vehicles, it could make sense. But in the long term, I think there will be a movement away from the usual oil or petrol gas.
Okay. Next question is from Kim. Hi all. I would like some clarification about nighttime delivery assumptions in relation to current nighttime vehicle movement restrictions and the availability of pickup drop-off facilities.
So yeah, I think in Vienna we have a very strict restriction during night. I'm not sure about this, but if we say that these vehicles don't cause too much noise, then I think there are not too many arguments against night delivery. So it should be viable from a policy side of view. And also the pickup and drop-off facilities, I think this is also connected to the next question by Barbara Lenz, how to hand over the deliveries and so on. I think there are some examples by Fernando already. I saw the link. And we think that these facilities will actually come before the AV delivery. So the AV delivery, we are talking about level 5 vehicles mainly. I think if they are really successful and they will launch as a business model, they will need to reach level 5, and this is in a quite far future. And personally, I think that before we reach that, we will establish a system where we have those parcel lockers or physical internet boxes where handover and delivery can be done without person contacts. So we assume that these infrastructures or these technologies are already given when we have a full penetration of automated urban delivery.
Thank you. The next question is from Barbara Lenz, but I'm not sure that it's for Bin or Fernando. How did you imagine the handling over of deliveries to receivers? Would we need storage facilities in buildings? If so, who would bear cost for storage?
Maybe I can take this one. I tried indeed to answer in the chat, but I'll try to summarize. Yes, Barbara is completely right that at the end of the day, this will create that the whole system is changed. So then we will need more storage facilities, either in buildings or proximity hubs. And here, for example, we see, and this is one of the topics we are addressing in our strategic dialogue group with Polis, how we can make these spaces available. And it's not only because of this; it's also because of all of the zero-emission type technologies has less autonomy, and this means that the hubs for city distribution will need to be closer to the city center. So there is, if we want to move to zero emissions, we also need to have closer the hubs for urban delivery, and this is indeed an important problem. In terms of parcel delivery, for example, in Spain, there is a company that is raising a lot of money out of investors that it's called Citybox. I share the link. And what they are doing is to reach agreements with the buildings. So the regular pigeons for the post are converted into a share delivery box. So then for all the people in that building, they access the whole box, not only their particular one, and then they have different dimensions, and then they do this for free for the building. But what they do is that then they have like an agreement that for companies to deliver in that building, they pay as a service. So to make use of that, they need to pay as a services, and it's working fine. Indeed, the Correos, the postal company, it's also looking into that future. And also, it's not dealing with automated vehicles, but more in general on urban freight and logistics. I have shared with you one reference from Professor Anne Goldchild on, and she was indeed pointing out on the problem that in many buildings, the problem is that the time for delivery in the whole building is so long that most of the time the vehicle is stopped and using part of the infrastructure in front of the building and not doing anything that it's profitable, and only taking the place. So then I share with you a reference into that as well. So I hope I managed to answer the question, but it's true that it's a question in the air still.
Thank you, Fernando. There is the next question from Simon Mader. I would be interested in the employment effects.
Yes, and if I may be more precise, I'm interested in the employment demand per unit delivered by an automated vehicle. Has anybody looked into that yet?
I would like to answer from Phil, Chris. I think it's there's not a straightforward answer. We have not looked into it directly, but what you see is that indeed a lot of work is being done, as mentioned before by Fernando and the other speaker as well, where the whole concept of city distribution is being re-evaluated. So if indeed you have proximity hubs, that will involve employment, but it will also be a combination of employment and automation. So you would probably have a combination of locker systems that have platforms already available that can interconnect with the consumer, but you will probably also have someone running the proximity hub. And then, of course, the handover from the autonomous vehicle to the proximity hub would be could still be done by the person running the proximity hub, but that is in full evolution, I would say. And then from the other side, the problem with drivers is real, so that would rather be a solution to a problem than creating unemployment. So, itself, I would say there are many things going on that are reshaping that whole landscape of city distribution. It's not a direct answer, but it's the best I can provide you with.
Thank you, Chris. I see more questions, but I also see that you have already answered them. But if I could ask you, Bin, to just say your answer also by speaking for the question. We assume that they will come before the AV delivery, but this is a valid, no, this is your answer. So the question was, I think Bin has already answered the question concerning the handling, but does the assumption about availability of delivery boxes in or around buildings also go into these calculations when he compares delivery with and without automation?
Not really. So we didn't take the cost into account, and this is a good comment. We will look into the costs. And in the scenario of status quo and the semi-automated delivery, I think we don't need those infrastructure, not strictly require those infrastructure, but in the full automated delivery scenario, we do. So therefore, this is a valid comment, and we should look into the calculations when we compare the costs.
Thank you so much for your answers. I don't see any more questions in the chat window. So I would like to thank you all that you participated during this Levitate webinar. I'm gonna send you information about Levitate and how to subscribe to our newsletter or how to join to our inside LinkedIn group for further discussions. This email is gonna arrive later today. And I would like to wish everyone a good day. Goodbye.
Thank you. Bye-bye, everybody.